Let's take a moment to review conic sections. So a conic section is literally what it says, but let's break down the name here. Conic number one means that there's a cone involved. So a cone in mathematics, remember from our study of chapter 12 with the vectors, a cone in mathematics is actually what you might call a double cone in the real world. It's got a top nap and a lower nap, an upper and a lower nap, and they meet at what we're going to claim is the origin here. And so this is a cone, and a conic section is the shape that you get by slicing a cone with a plane. So the section here in this sense means a slice in the mathematical sense. So there are 3 or 4 or maybe 5 types of conic sections depending on how we think of it. So let's try to build them all. Let's start with the simplest one, and that is if we just slice our cone through the origin, so through the point where this meets here, then this is just a point. So this is a trivial conic section. We're not really going to study this, but a point is technically a conic section where the plane, the slice, goes right through the point where the cones meet, the vertex of the cone. That's not so interesting, right? So we're not really going to study, well, we do study points, but we're not going to study it from the point of view of a conic section. Now this plane that I've drawn here, think of this as the xy plane, and then the upper nap of the cone is above the xy plane, and the lower nap is below, of course. So the next thing I want to do is slice the cone parallel to the xy plane. So there's a slice of the plane up above the xy plane, but it's at a different height, so it's not going through the point, the vertex there. And when it slices our cone, this is going to leave us with a circle. So the second kind of conic section is a circle. And a circle is obtained from a cone by slicing the cone with a parallel plane to the xy plane. So parallel to the floor, if you think of three-dimensional space as being the room that you're sitting in. So a circle is a conic section. Now we start to get a little clever here. So what if we take our plane, instead of slicing with a parallel plane, I'm going to slice the lower nap now. By the way, we should label these. So the circle is the red. The point is the green here. The next thing I'm going to do is slice the lower nap, just so we can see what's going on. Slice the lower nap with a plane that is not parallel to the floor. Okay, so this magenta slice right here, this is not parallel to the floor, but the idea is that it does cut through the single nap. It cuts through the lower nap by itself, and this traces out a curve that looks something like this. And in your mind, think about what that might be. It's a closed curve, but because of the slant here, it's not going to be a circle, so this is an ellipse. So ellipses, these are conic sections. So these correspond to slices of the cone where the plane still crosses through just one nap and it never touches the other nap, but it does it at an angle that's not parallel to the xy plane. Okay, there's 2 more ways to slice this. I think we should get a new picture here so that we're not cluttering things up too much. So I'm going to go to a new page, but don't forget these. These are important. The point, the circle, and the ellipse. And for the next 2, maybe we'll do each one individually. So it's the same idea. We want to slice our cone with a plane and look at the image on the plane. So we just sliced with the magenta plane down here that was slanted. So I'm going to slice up above now. Let's say we slice our upper nap of the cone with a plane that is a plane that now cuts the upper nap, but it doesn't ever meet the other edge of this nap, okay? But it also, so it's maybe this plane is parallel to the axis here, so that it doesn't cross over this edge of the upper nap again, but it also doesn't intersect the lower nap in any place. And think about what this curve is going to trace out. So this curve is not going to be closed because as you go up the cone, it's going to just get wider and wider and wider. And so this will trace out, at some point it'll reach here, and this is going to trace out a parabola. So a parabola is a conic section. A parabola is a conic section that is obtained by slicing one nap of the cone in a way that it doesn't intersect the cone itself again, and it also doesn't intersect the lower nap of the cone. All right, so that's a parabola. And then there's one more thing we can do. So we are kind of gradually tilting our plane. So we started with horizontal, another horizontal but at a different height, we tilted the plane, gave it some slope, and then we gave it even more slope to get our parabola from our ellipse. And so you can imagine that the next, and this happens to be the last type of conic section, this one is obtained by slicing, by turning this plane even more vertical, closer to vertical. And so this slice is, I'll just draw it as a vertical slice, but if we were to cut through our cone with a vertical plane like this, this is going to cut our plane. Now this is supposed to, the picture is supposed to show that this one cuts the upper nap and the lower nap of our plane, of our cone, sorry. So this one might cut over here, get a curve that looks kind of like a parabola, but at the same time it's cutting the lower nap as well. And so if you were to kind of pull this plane out and have a better look at it, the way I've drawn it, this would not be a function, but this kind of curve is called a hyperbola. Okay, so hyperbolas are also conic sections. All right, and so what we've seen here is that circles, we're comfortable with circles, I think. Points, of course, we're comfortable with points. But the three types of conic sections that we're going to study in the next two sections of the notes are ellipses, parabolas, and hyperbolas. And we're going to study these from the point of view of the conic section. And we're going to write down some definitions of these that you might have seen, I hope, but maybe not. And so in that case, pay close attention.